Hi, I am Lopa Sen. Welcome back to my channel Electronic Science Tutorial. I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not follow my channel, please follow my channel. If you like my channel, then please like, share and subscribe my channel. So let's start our class. Welcome back to my channel with a new lecture series on semiconductor device, that is breakdown diode. It is very much important topic for you guys, those who are trying to crack NTA UGC NET exam for electronic science, and also it is very important topic for West Bengal SET exam. In unit 1 of the electronic science syllabus, this topic is placed. In previous class, I already talked about the semiconductor physics and the PN diode. Those who are not check out my channel, please follow and do like, share and subscribe my channel. So let's begin our class. Our first topic is avalanche breakdown. Breakdown diodes are PN junction diodes which operated in the breakdown region of the reverse voltage characteristic. And these diodes are designed with sufficient power dissipation capacities to work in the breakdown region. There are two mechanisms for breakdown diodes in a junction diode. One is avalanche breakdown and the other one is Zener breakdown. So our first topic is avalanche breakdown. When we increasing the reverse bias voltage, the electric field across the junction of a PN junction diode increases. So our first point is when we increasing the reverse bias voltage, the electric field increases across the junction of a PN diode also increases. Okay. So at a certain reverse bias, the electric field imparts a sufficiently high energy to a thermally generated carrier to cross the junction. These carrier collide with a crystal ion on its way and disrupt a covalent bond, and now this carrier produces a electron hole pair which is newly generated. So the second point is the thermally generated carrier colliding with crystal ion with its own way and disrupt a covalent bond and produces a new electron hole pair. Okay. So these carrier can also gain sufficient energy from the applied field and collide with other crystal ion to generate further electron hole pairs. Right. So this process is cumulative and produces an avalanche of carriers in a very short time. Okay. This mechanism is known as avalanche multiplication process, which causes a large reverse current. The next point is the avalanche breakdown takes place in a junction having a wide depletion layer. With a rise of temperature, the crystal ion vibrate with a greater amplitude, which increasing the possibility of collisions of the carriers and the crystal ions. The carriers thus have less opportunity to pick up enough energy between collisions to trigger the avalanche process. So, the avalanche breakdown voltage increases with a rise of temperature, which is higher than 6 volt. Okay. So the temperature coefficient of the avalanche breakdown voltage is positive. So these 7 points are the important point of avalanche breakdown process. Okay. In next slide we talk about Zener breakdown. The next point of breakdown mechanism is Zener breakdown. So what is Zener breakdown? Zener breakdown occurs when the reverse voltage across a PN junction is sufficiently high so that the resulting electric field at the junction exert a large force on a bound electron to tear it out of its covalent bond. So this is the first point. Second point is a direct rupture of the covalent bonds produces a large number of electron hole pairs, which increasing the reverse current. Okay. This process is referred to as Zener breakdown process. Unlike avalanche breakdown, Zener breakdown does not originate from the collision of carriers with the crystal ion. Remember it. Unlike avalanche breakdown, Zener breakdown does not originate from the collision of carriers with the crystal ions. Okay? For heavily doped diodes, Zener breakdown occurs at voltages below 6 volt. And for lightly doped diodes, the breakdown voltage is greater and the avalanche multiplication is predominant. Okay, so there are two different mechanisms. Breakdown diodes are commonly referred to as Zener diodes. Okay, Zener diodes or Zener breakdown occurs in a junction having a narrow depletion region. With a rise of temperature, the energy of the valence electron increases so that a lower applied voltage can pull these electrons out of their covalent bonds. So the Zener breakdown voltage decreases with increasing temperature, which is less than 6 volt. That is, the temperature coefficient of Zener breakdown voltage is negative. So these all are the 6 important point of Zener breakdown. I hope you understand these two mechanisms. Thank you. Thank you. With this, we have come to the end of our session. I hope you like this video. If you like my channel, please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.